Hello everyone, and welcome to this video titled Domain and Range of a Function. In this video, I'm going to be going through several examples taken from the adaptive practice for a website called ck12.org, and I'm in their Algebra 1 text. All right, so here we are in the adaptive practice from ck12.org from the Algebra 1 text, in the section called Domain and Range of a Function. All right, so as I work through this, I'm going to go through 5 of the 10 examples in the practice and leave the rest for you to try on your own. And of course, after you're done with the 10, you can go back and practice even more, practice to your heart's content. So try to follow along. And I would recommend too, when I start a new example, pause the video and then try to work it out yourself before watching me do it. See how you can compare your work to mine or your thoughts to mine. All right. So here in this first example, we're asked to name the range in the below points. All right, so we're given some points, or what are sometimes called ordered pairs. We have the ordered pair 2, 5, and the first value in an ordered pair is typically referred to as the x coordinate or x value. The second value after the comma in the ordered pair is typically referred to as the y coordinate or y value of the pair. All right, so we have 2, 5, then pair 3, 6, and the pair 4, 7, and finally the pair 5, 8. We're asked again for the range of this set of ordered pairs. All right, so first I'm going to write this out. Pull up my scratch pad here. So yes, we had the ordered pairs, 2, 5, 3, 6, 4, 7, and 5, 8. Right. Now, before we get into the domain and range here, well, I'll get to it now actually. In a set of ordered pairs like this, now a set of ordered pairs, a collection of ordered pairs like this is sometimes referred to as a relation, R-E-L-A-T-I-O-N. And the domain, the title of this is Domain and Range of a Function. The domain is the set of x values in the ordered pairs. Sometimes those x values are called the inputs or the x coordinates or first coordinates, whatever. So in this particular set of ordered pairs, all right, the domain is, all of the x coordinates, right? So 2, 3, 4, and 5. So I'll write those in red here. 2, 3, 4, and 5, right? Make the domain of this set of ordered pairs, the domain of this relation. And then the range is just the set of all the y values or the y coordinates or the outputs. So it's the set of the y values or the outputs or the second coordinates, y coordinates, right? So here, in this particular example, and I'll do this in a different color, say blue, the y coordinates of these pairs are, 5, 6, 7, and 8. And so that's what I will write in my set notation here, right? Little curly braces, right? And then I'll highlight this in blue again. So yeah, the range is the set of values 5, 6, 7, and 8. Okay. So that's our answer. The set with 5, 6, 7, and 8, which I will highlight up here, that's choice B. But before I do, I want to talk about the definition of a function, as this is called the domain and range of a function. So we have our domain, the set of all the inputs or the x coordinates, x values. We have our range, right, the set of all the y values or outputs or second coordinates, y coordinates. A function. So again, 5, 6, 7, 8. I'm going to clear this. I'm going to erase some of it. Just erase the stuff. Domain here. A function is a special kind of set of ordered pairs. In a function, get to the pen tool again. So, oh, that's way too thick. So in a, that's also super thick. Yeah, all right, let's go here. So capital F there. So in a function, it's a set of ordered pairs where each domain value, right, each value in the domain is paired with exactly one value of the range. Each value in the domain is paired with, so in an ordered pair with, only one value of the range. Now, paired with might also be referred to as mapped to, so paired with slash mapped to exactly one. Okay, exactly one. So not none, not two, not three, all right? Exactly one value of the range. Right? That is the definition of a function. So in our particular example here, now you can represent a function or you can represent a relation in multiple ways as what's called an arrow diagram, or you could represent it as a graph on the xy plane, right? We have x coordinates and y coordinates. So one way I could represent this function here, or this relation, sorry, and see that it's a function is I have, say my domain values, right? My set of x coordinates, I'll write them on, to the left here. And then I have the set of y coordinates. I'll put those y coordinates off to the side, and don't write repeats. If anything repeats, don't write it again. There's no need for that. So 5, 6, 7, 8. So I've got my domain values to the left, the outputs, the range values to the right. And then we can draw arrows. Whenever there's an ordered pair, like you see the ordered pair, 2 comma 5, that means 2 is paired with 5. 2 from the domain is paired with 5 from the range. And 3 is paired with 6, 4 is paired with 7, and 5 is paired with 8. So if I was drawing an arrow diagram to represent this, I would draw an arrow. 2 is paired with 5, little arrow 2 to 5. 3 is paired with 6, 3 to 6. 4 is paired with 7. 5 is paired with 8. And that's what they call an arrow diagram to represent a set of ordered pairs of relations. Now notice every single value in the domain, 2, 3, 4, 5, has exactly one arrow coming off of it. Right? So because of that, the definition of a function is satisfied. This set of ordered pairs would be called a function. And you could also do it with coordinate axes. So I'm going to draw, you have a vertical axis, a horizontal axis, right? And typically the horizontal axis, these are number lines. The x-axis is typically the horizontal one, y-axis vertical. On the x-axis, positive numbers to the right, negative numbers to the left, 0 in the middle. And then on the vertical axis, 0 in the middle, positive numbers going up, and negative numbers going down. But these are two number lines. And then we would plot each ordered pair as a point on this plane. So for the ordered pair 2, 5, I go to positive 2, there's 1, 2 on the x-axis, and then positive 5 on the y-axis, and then plot the location that is in line with both of those, and that would be this location right here. So there's the point 2, 5, right here. And I would do the same for 3, 6, go to 3 on the x, 6 on the y, plot this location probably around here, and then 4, 7, and 5, 8, right? I'll just write up one every time. 4, increase x by 1, y by 1, x by 1, y by 1. Oh, you'd have these 4 points here. Sorry, I went over the word range, but and then you see every single value of x is mapped to or corresponds to exactly one value of y. So again, we can say we have a function, right? So that was a lot of explanation for this one problem. Now, but back here, the range though was, the y coordinates 5, 6, 7, and 8. So I'm selecting B, checking it out. I just wanted to get some definitions out there for maybe future problems. Okay, so moving on. All right, so my next example, so this is determine the domain and the range of the following relation. All right, so again, you got a relation, a set of ordered pairs. The domain of a relation is just the set of the x coordinates, all the first coordinates here, 0, 3, and 90. So of these choices, the only one with the correct domain is D, right? 0, 3, and 90. Well, let's also make sure the range is correct, right? The range is the set of the y coordinates, the second coordinates in the ordered pairs. So the values that are in the range would be 4, 20, and 33. And you're seeing that also in selection D here, the set with 4, 20, and 33, all the y coordinates, the second coordinates of those ordered pairs. So I'm going to select D, right? The domain and range are these two sets. Also, they call this a relation. It would be a function as well, right? Every value of the domain, right, 0, 3, and 90 is paired with exactly one value of the range. Again, exactly one, not none, more than one. 0 is paired with 4, and that's it. 3 is paired with 20, and that's it. And 90 is paired with 33, and that's it, right? So this would also be called, a function, right? It's a special kind of relation. Check that out. Wonderful. And let's move on. All right, so now we're not just given a set of, 4 ordered pairs or just 3 ordered pairs like in the first two examples. Here, again, we have I mentioned the coordinate plane earlier, right? We have the horizontal x-axis in thick black here. going horizontally. And then going vertically, right, we have this thick y-axis. And then the graph of the ordered pairs we're looking at, right, the picture of the ordered pairs in our function is this blue, all these blue ordered pairs, right, making this parabola shape or kind of a U shape, a wide U. So this doesn't have just 3 ordered pairs or 4 ordered pairs. When you see a graph that's like connected like this and drawn out with, you can draw a bunch of ordered pairs without lifting your pencil. That is infinitely many ordered pairs, right? Infinitely many. And they're asking us to look at this graph of infinitely many ordered pairs. And then they ask us, what is the value of this function's input when the function's output is 1? So remember what I said earlier. Input is the x-coordinate, a value on the horizontal axis, the x-axis. Function's output is its y-coordinate. So they're giving us function's output is 1. The y-coordinate is 1. So you see where my cursor's floating around here. I'm looking on the y-axis. When y equals 1, right, we're here at this point on the bottom of the parabola, the bottom of the blue curve. I'm at this point right here where my cursor is hovering around. Hopefully you can see that. That's when y is 1. And you see that point there when y is 1? Look at the value below on the x-axis that has an x-coordinate or an x value of 0. All right, so when the output is 1, the input must be 0 for this particular function. And that's what I'm going to enter. When the output is 1 for this function, the input must be 0, or the x-coordinate, the x value underneath that point. And then they would say, input 0, output 1. 0, 1 would be the ordered pair, representing that point here. My cursor is floating around now at the top of the screen. All right, moving on. All right, so here's example 4. Again, we're given a graph. Now this time, the last graph in example 3, it was a smooth curve. There were no gaps in it. You could draw it without lifting your mouse or without lifting your pencil. That had infinitely many points, infinitely many ordered pairs. This one, dot, 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 dot. There's just 4 points, 4 ordered pairs. And in fact, I will go down into my scratch pad. Scrolling up and down here, I'll list these 4 ordered pairs, right? The last graph I had infinitely many, so I couldn't possibly list them all. But here I can list them. And what we're doing is, this graph, right, represents a set of ordered pairs, a relation, and we're asked to just enter the domain of that relation. All right. So again, in my scratch pad, here's the relation. I'll describe this relation, write it as a set of ordered pairs. So one ordered pair, so I'll start with the parentheses here. I'll do this point, right, this bottom point of the 4 points. Now you see that's that's in line with 1 on the x-axis and 1 on the y-axis. So it would have coordinates 1, comma, 1. There's one ordered pair. Next ordered pair, point above that, in line with 1 on the x-axis, 2 on the y-axis. All right, so this would have coordinates 1, comma, 2. And then close the parentheses. There's the end of that ordered pair. That represents that second point from the bottom. The third point from the bottom of these four. One with the x-axis and in line with 3 on the y-axis, right? So the ordered pair representing that point is 1, comma 3, right? That's coordinate 1, y coordinate 3. And finally, the fourth point, the fourth ordered pair, the top one being drawn here is in line with 1 on the x-axis and 4 on the y-axis. So that is coordinates 1, comma 4. And then I'll close the braces, right? Here we have it. That graph we were given represents this relation, this set of 4 ordered pairs. And we're asked simply to state the domain. Remember from earlier, right? The domain of this relation. Now I'll do the domain and the range. The domain is again the set of the x coordinates. Well, look, every single x coordinate is 1. And so that is the only value in the domain. There's no need to write repeat values. So the domain is simply the set with the number 1 in it. That is the only x coordinate. All right, now I'll also do the range, right? We're going to enter this domain in a second, but the range of this relation, again, it's the set of the y coordinates, all these second coordinates, right? Which are 1, 2, 3, and 4. So in this curly braces, right? 1, comma 2, comma 3, comma 4. There you go. All the y values. Now, I'll make a little arrow diagram from these. All right, let's do some orange arrows. Remember the arrow diagram I set up earlier? Now I had the values of the domain on the left, the values of the range on the right. We can use this top and bottom here if we want. And, 1 is paired with 1 in the relation. 1 is also paired with 2. Right? There's 1 comma 2 as an ordered pair. 1's also paired with 3. 1 from the domain is also paired with 4 from the range. So look at that arrow diagram I just drew, and they have a graph of it above. Does this satisfy the definition of a function? No, it doesn't. No, it doesn't, right? In a function, one more time, in a function, every value from the domain is paired with exactly 1 value from the range. Not more than 1, not less than 1, exactly 1. So here, the only value in the domain, see it, this is paired with 4 values from the range. That's more than 1. So this relation is not considered a function. Okay, but again, that's neither here nor there. Right. It's just simply for the domain with the curly braces, right? So I'm entering curly braces, number 1, and then close the curly braces. That's it, right? This is the domain. All right. I'm going to do one more. Like I said earlier, 5 examples. All right, so once again, we're given a set of ordered pairs in the form of a graph. And it's another one of those where there are just 4 points, 4 dots. They're not connected. You're not drawing a smooth connected curve here. If you have to lift your pencil like this, just draw 4 dots. There's only 4 ordered pairs, not infinitely many, like in that example 2 with the parabola or example 3, I forget already. So we're given 4 pairs. Now I'm not going to draw these this time, but we have the ordered pair 1, comma 4, right? That represents this point. 2 on the x, 3 on the y, 2 comma 3 for that point. And this point here, where my cursor's floating around, that'd be 3 for x, 2 for y, right? 3 comma 2. And then this last point, the relation is 4 for x, 1 for y, 4 comma 1. Now notice how every single x value in the domain has just one point above it, right? So what this represents a function. This is a function, this relation. Every value of x in the domain maps to or corresponds to or is paired with exactly one y value, right? There's exactly one point above each x value. So if you were asked, is this relation a function? The answer would be yes. Right? We are asked for the range. And remember, the range is just the set of the y coordinates. So, this point here has a y value of 1. This point here has a y value of 2. This point here has a y coordinate of 3. And this point on top has a y coordinate of 4. So 1, 2, 3, and 4 are my y coordinates. So I'm going to put little curly braces. 1, comma 2, comma 3, comma 4, right? Those would be the y, and close the curly braces. Those would be the y coordinates of all these points in my relation, my function, and therefore that set of 4 values are, make up the range. Wonderful. All right, and that's all I'm going to do. All right, so we saw here in this video the definition of, a relation, right? A set of ordered pairs, the domain of a relation, set of all the first coordinates of the ordered pairs or the x values, the inputs, the range, right? The set of all the y coordinates, the second coordinates, the y values, the outputs of the relation, and the definition of a function, right? Function is a set of ordered pairs, a relation where each value of the domain is paired with exactly 1, not less than 1, not more than 1. Each value of the domain is paired with exactly 1 value of the range. And I hope that you continue to practice here, right? Go to ck12.org's Algebra 1 text. Look at this section, read it, practice it as much as you want until you get the stuff mastered. And hopefully this video helps you out while you're doing that. And thank you very much for watching.